Hi, Integrated Math 1. Welcome to lesson 2.4.3b, last lesson of our lovely unit. We're going to do activities 3.3, 3.4, and 3.5 today. So we're starting off on page M2-292 in your lovely workbook. Now, last time we started looking at perimeters and areas of a composite figure, right? Which meant it was some strange shape, but we discovered that, of course, we could chop it into shapes that we could work with to make it easier to find the area, right? That we could cut it into triangles and rectangles and all kinds of things because we can easily find the area of triangles and rectangles. So we're going to be playing with that a little bit more today. So to get us started, I actually used to have a bedroom like this. Ada's bedroom is on the top floor of her house. And in her room, the roof slants downward, creating two congruent trapezoid-shaped walls. So one of the walls in her room is represented on the coordinate plane by quadrilateral A, B, C, D. And each interval on our coordinate plane is 1 foot. You can count. See, we're counting by ones here. So again, this is just one wall, but of course they're on opposite sides of the room. So she actually has two walls that look like this, but we're just working with the one on the graph right now, and we'll just double whatever we need to double, right, for both walls. That's how it works. So Ada and Marco are going to paint the two walls, and they want to place a strip of painter's tape along each edge. If you've ever done painting before, you do want to make sure you get that painter's tape up there. It makes it a lot easier to do the job. So the paint won't touch any of the other walls. You won't get paint on the ceiling. You don't get paint on the floor, that kind of a thing. So my question for you to get this party started is, what is the length of painter's tape to the nearest whole foot that Ada and Marco need to be able to cover the edges of both walls? Okay, go ahead, hit pause to see what you can do with this, and then hit play when you're ready to check your work. So first thing, I need coordinates. I need coordinates, right? I don't know what these coordinates are. So real quick, it looks like A, I'm going to write down these coordinates. Looks like A is at -7, -1. So make a little note there. It looks like B is at 6, 3. It looks like C is at 6. Oh dear, my poor little pen. I got you, little pen. I got you, buddy. It looks like C is at, what is that, 6, -5. And D appears to be at -5. Oh, I put a -7. That should be a -5, not T, Miss Scott. Oh my goodness. I'm making all kinds of mistakes. Yeah, we make mistakes. That's why we fix them. So sorry, that should be -5, -1. And that means D is at -5, -5. So I'm just making a quick note of this here, and here's why. If I want to find the length of painter's tape that's going all around the edge, I'm looking for the perimeter. And some of these sides are really, really easy to find because I can just count them, right? Side BC, 1, 2, 3, 4, 5, 6, 7, 8 feet over here, right? Side DC, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over here. And side AD is also pretty easy to count, 1, 2, 3, 4, boom. Problem is side AB, because it's slanted, I'm going to have to use some distance formula. So that's why I went ahead and wrote down the points. So let's use distance formula to find side AB. So we'll subtract our x coordinates, -5 minus 6. We'll subtract our y coordinates, -1 minus 3. Of course, -5 minus 6 is a -11. -1 minus 3 is a -4. When we square them, we get 121 and 16, which together gives us 137. And when we do the square root, we get about 11.70. So I'm just going to put 11.70 here. It's about what that is. And of course, we already said, hey, AD is 4, CD, DC, whichever way you want to say it is 11. And we said that BC was 8. So let's just go ahead and add these all together. So I did that. When I added them all together, I got about 34.70. Now, here's the thing. This 34.70 feet is how many feet it takes to do painter's tape around one wall. But you'll notice we're painting Both walls. So I'm going to make sure that I double this so that we get enough painter's tape for both walls. Nothing the worst being in the middle of painting and being like, crud, I got to go back and get some more. So I went ahead and doubled it and I got about 69.41. It did say to round to the nearest whole foot, did say to do that, nearest whole foot. So I'm going to go ahead and round that then to a good 70 feet because I don't want too little painter's tape, right? That wouldn't be good. So it looks like Ada and Marco need about 70 feet of painter's tape. So now they know how much painter's tape, but we need paint, right? That means we got to figure out some areas, don't we? So Marco says he can draw a diagonal to divide a trapezoid ABCD into a right triangle, sorry, that's such a triangle, and an isosceles triangle to determine the area of the trapezoid. So Marco says, hey, I can draw a line. I'm going to grab my little blue pen here. Marco says, look, I can draw a line diagonal. Ooh, sorry, badly drawn line. Badly drawn line. Marco says, I can draw a diagonal line from A to C, and that would make a right triangle and an isosceles triangle. And he's like, I could do that. That would help me like find the area of each one of these, right? But Ada says she wants to do it differently. She says she can draw a horizontal line segment to divide our trapezoid into a rectangle and a right triangle. So Ada, ooh, helps if I hit the right buttons. Ada says, I don't think you should do that. Ada says, what if we just draw a horizontal line from A and right across? And that way we have a right triangle and we have a rectangle. So Ada's saying, what if we did that? And so the question is, who's correct? Who's right about how to divvy this up? Go ahead and hit pause, jot down your thoughts, and then hit play when you're ready to check your work. Hopefully you guys have realized after our last lesson, both are correct. Both of them are correct. Both of them are right. Marco could draw his diagonal AC, right, and have that isosceles triangle, and it would have a base of 8, and it's easy to see the height of 11. And then it also has a right triangle with a height of 4 feet and a base of 11 feet. So Marco can do it that way. That would work. But of course, Ada is also correct. Ada could draw that horizontal line from vertex A just straight across to create a right triangle on top with a base of 11 feet and a height of 4 feet, and a rectangle with a base of 11 feet and a height of 4 feet. Both ways of doing it work. Both ways of doing it are correct. So you know what I'm about to ask you to do, right? You're going to need to find the area. I don't care which method you use. Pick a method, use it, love it, cherish it. But here's the deal. 1 gallon of paint covers approximately 400 square feet. Ada doesn't have a full gallon of paint. Ada estimates she has about 1/4 of a gallon of paint remaining of the color that she wants to use. So my question is, does she have enough paint for both walls? Do your work, work it out. See what you can tell me. And of course, hit pause to work that out. Hit play when you're ready to check your work. All right. Either way you divide it, you could have done Marco's way of drawing that diagonal from A to C. You could have done it Ada's way by drawing straight across. Either way is correct. Me personally, I went ahead and drew it straight across. I was just like, it's just easier that way. It's just easier that way. And so I went ahead and drew it straight across. I liked it better that way for me personally. You may have felt differently. And that way it was easy, right? We already know this side is 11. We already know that this side is 4. And then of course for our triangle, that means that this base of my triangle is also 11. And the height of my triangle, turns out it's also 4. So that means I can find the area of my triangle. And just so that we have a letter here, just to make it easier, I'm going to call this point E. You can call it whatever you like. I'm going to call it point E just so I have a point of reference. So triangle ABE, well, area of a triangle is 1/2 base times height. So 1/2, 11 times 4, which means I end up with 22. You know how to find the area of a rectangle. So if I want to find the area of rectangle ADCE, find base times height. So I'll just do 11 times 4, which gives me 44. And that means my entire wall, if I add those two pieces back together again, my entire wall is 66 square feet. Here's the thing though, remember, she's painting both walls, right? She's painting both walls. So we're actually not trying to cover 66 feet. We got to double that. She's actually trying to cover 132 square feet with paint. Now here's the other trick. Remember a gallon was 400 square feet, but she only had a fourth of that gallon. So if I take that 400 and I divide it by 4, she only has enough paint to cover 100 square feet. I would get her for one wall, but it definitely wouldn't cover both walls. So Ada does not have enough paint for both walls. Guess she could just do one wall. Or she could go get more paint. I guess it's up to her to decide, isn't it? Either way, we got a painting problem here. Let's move on to building stuff. Maybe instead of painting, let's make a gazebo. Emma and Kevin are designing a gazebo for the local park. And the polygon on the coordinate plane represents the base of the gazebo. It's going to be our platform for the gazebo. Each interval on the coordinate plane represents 2 feet. So do pay attention to that. Notice we're counting by 2s. That's why you always got to label your graph so you know what's going on. We are counting by 2s. The other thing is make sure you got the right numbers here. This should be a -17. My poor little slide accidentally said 18, and so that's why it's all wonky. But it should say 17, -17 in your book. Sorry about that. So we've got our points. The base of the gazebo needs to be built with links of lumber around the outside to support the floorboards, right? You don't just put the floorboards on the ground. No. You build that little structure so that you can put the floorboards on top of it. So the base of the gazebo needs to be built with links of lumber that are just going to come around the outside to support those floorboards that we're going to lay down. So my question is, what is the length of lumber needed for the outside of the base? Go ahead and hit pause to see if you can work this out, and then hit play when you're ready to check your work. All right, well, this said to me that this is a perimeter problem, right? When it's all like around the outside, I was like, oh crud, this is a perimeter problem. So I need to know the lengths of all these sides. And some of them weren't that hard to find because you could just count them, right? The horizontal guys, you could have just counted them, right? 2, 4, 6, 8, 10, 12, 14, 16, and another one. It looks like the length of that guy is 17. It's probably going to be the same over here, right? 2, 4, 6, 8, 10, 12, 14, 16, and another one. So it looks like that side is 17. The others are slanted. You know what this means. We got to do distance formula. So I got to do distance formula like 4 times here. Hopefully it's all the same, but I don't know. They didn't say it was, so I better double check that. So I'm going to go ahead and do distance formula. We'll go ahead and start with side AB. So I'll subtract my x coordinates, 0 minus a -15. Subtract my y coordinates, 16 minus 8. Double negative becomes a positive. So we have 15 squared plus 8 squared. Square them, you get 225 and 64. Together, that's 289, which is a perfect square. We got 17. So it looks like side AB is also 17. Nice, I can handle that. What's up next? Let's do side BC. We already know side BC. We said BC was 17. If you weren't sure, you could have just subtracted the y coordinates to verify that. 8 minus a -9, 17. Okay. Let's do CD next. So again, we will subtract our x coordinates, -15 minus 0, and subtract our y's, -9 minus a -17. Of course, the double negative becomes a positive. So when we put these together, we get -15 and an 8. If we square them, we get 225 and 64. Are you having deja vu? I feel like I am, because I just got 17 out of square root of 289, which is 17 again. So it looks like this side is also 17. Let's keep working our way around. DE, subtract our x coordinates, 0 minus 15. Subtract our y coordinates, -17 minus 9. Double negative becomes a positive. We have negative 15 squared and negative 8 squared, which is 225 and 64. Together, it's 289. And once again, we just found out that this side is also 17. We already knew FE was 17, but if you wanted to double check, since the X coordinates are the same, you could have just subtracted your Y coordinates and been like, oh, hey, that would have worked. Last but not least, AF. So we'll subtract our X's, 0 minus 15, subtract the Y, 16 minus 8. So we have a negative 15 and an 8. You square them, you get 225 and 64. And again, we get 289. And again, the square root of that is 17. Wow, so they did a good job setting this up. It looks like all of the sides are 17. What a perfect little hexagon. So beautiful. So that means if I want to find the perimeter, you can do 17 plus 17 plus 17 plus 17 plus 17 plus 17, or I'm lazy. I just did 6 times 17. So it looks like it's 102 feet of lumber that we're going to need to build the outside of the gazebo. There is an extra E in there. I am sorry for that. You want to see if I can fix it? I bet I can fix it. Maybe I can fix it. Maybe I can't fix it. Maybe it's there forever now. It bothers me. Hang on, I'm going to scribble it out. There's not an E there. Go away. It doesn't want to go away. Wow, it is determined to stay. Okay. A total of 102 feet of lumber is needed to build the outside of the base of the gazebo. Great. But I got to put down floorboards. I got to put down floorboards, right? I got to put down floorboards. So the question is, how many square feet of floorboards are needed for the base of the gazebo? Yeah, work it out. Make sure you show your work. You may want to put a little description in there. There's all kinds of different ways to chop this up to make it easier, but see if you can chop it up into some rectangles and triangles. It'll make it better. Go ahead and hit pause to find out how much floorboard you need, and then hit play when you're ready to check your work. So I realized I could cut this up into 3 easy chunks. And you may have chopped yours up differently, and that's okay. But I realized I could draw a line straight across from B to F, and I'm like, look, there's a big triangle. Ha ha ha. And I looked at my big triangle, and I was like, well, the base of my triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and one more is 30. Whew. All right, so I got a base of 30. Sweet. Ooh, I can even find the height of this triangle. Check it out. 2, 4, 6, 8. Oh, bam. I got the base and the height of my triangle. And so I thought, let's do it again on the bottom. So I did it again on the bottom because, again, this means I have a base of 30. Again, this means I have a base of 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, dear. This guy can't count very well. Oh, because it's off, because that should be at 17. That's why, because it's off. That should be at 17. So 1, 2, 3, 4, 5, 6, 7, 8. So sorry, it should come to here. But that means we also have a base of 8 over there. And I can easily find that out. And of course, now look at what I have in the middle. I have a rectangle in the middle. It's so pretty. I already know the base of my rectangle is 30. And in fact, we already found side BC and side FE. I know the height of that rectangle. It's 17. We did it earlier. Great. So if I want to find the area of this top triangle, ABF, 1/2 base times height. I got 120. If I want to find the area of my rectangle, base times height, which means my rectangle is 510. And of course, same thing for this little bottom triangle. It should match the top triangle. Again, it's right on your paper. Sorry, mine's funky. Which means that I have triangle CDE. Again, base times height, cut it in half, means again, I have 120. So the total area for this base, if I add those up, will be 750. So I need a total of 750 square feet of floorboards that's going to be needed for the base of the gazebo. Yeah. Sorry, my picture on the screen was a little off. I mean, the picture in your book isn't, but the picture on my screen is off. That makes me sad. One last little thing that we're going to talk about, and it's actually going to be a little bit easier and even kind of touches a little bit on calculus. Oh, that's right. I said it, integrated math 1, and we're already working in that direction. This graph shows the constant speed of a car on the highway over the course of 2.5 hours. So you can see I have my time here on the bottom, my hours. You can see 2.5. And you can see my speed up here is in miles per hour. And it was a constant speed. So it looks like for the entire 2.5 hours, I was driving at 60 miles an hour. Just fair if you're on the highway. In fact, sometimes it might be a little slow. People ride up all on your backside. It's not cool. Can you describe to me how you could calculate the distance the car traveled in 2.5 hours using what you know about area? Hit pause. Jot down, you're not working it out just yet, but just how would you find that? Jot down your thoughts and then hit play to keep the discussion going. There's an old formula. Have you seen this formula before? Your 7th grade teacher may have called it dirt, but it's distance equals rate times time, right? So you may have heard this formula before. That's not really new to you or anything like that. Well, remember that rate is another word for speed, okay? That's how fast you're going. And of course, time, you know what time is. We're not gonna make a fuss about that. So distance equals rate multiplied by time. Well, I can see that my rate is 60 miles an hour, and I can see that my time is 2.5 hours. So they said to describe it in terms of areas. What we're actually finding here, even though, yeah, we're trying to figure out how far we drove, but in terms of this graph, since our graph has time and our graph has a rate on it, because that y-axis represents the rate and that x-axis represents the time, when we're finding the distance, we're actually finding the area of our rectangle, right? Base times height, right? Base times height. So the area of this rectangle actually represents the distance that we traveled. It's deep, huh? That's deep. So my question for you then, how far did the car travel in 2.5 hours? Hit pause, work it out. Hit play when you're ready to check. So dirt, distance equals rate times time. And of course we said base times height. Well, my base is 2.5, my height is 60. So I multiplied them together and we did 150 miles in 2.5 hours. Awesome. That wasn't so bad. This graph that we just used is what we call a velocity time graph. And in a velocity time graph, you might want to underline this or something. In a velocity time graph, the area under the line or the curve gives the distance. True story, yeah. So this graph shown describes the speed and the time of a passenger jet's ascent, right? Passenger jets, they got to pick up speed, right? When they go up into the air, and you can see he's getting faster and faster and faster until he hits 600. And then he's like, cruising along at his 600 miles per hour. Must be nice. And of course, you can see our time along the bottom. So how could we use the graph to determine the distance the jet has traveled in 25 minutes? Hit pause, jot it down, hit play to keep the discussion going. So we just said that in a velocity time graph, the area under the curve gives the distance. So guess what, guys? You want to know how far that jet plane went in 25 minutes? Find the area. Yeah, you can calculate the area of that region in their graph there, enclosed in the graph, from 0 to 25 minutes to determine the distance the jet traveled. Now, I will warn you. Please notice that this time is in minutes, but our speed, see minutes, but our speed is in miles per hour. You may need to do a little bit of adjusting, okay? You may need to do a little bit of adjusting to answer part A. Determine the distance the jet has traveled in 25 minutes. Remember, you said you could find it by doing the area under the curve. So make adjustments between minutes and hours. Find the area under that curve. Boom, you will have the distance the jet traveled for that 25 minutes. So go ahead, hit pause, do the math, do the work, and then hit play when you're ready to check your work. All right, let's do this thing. First of all, my thought was, you know what, if I chop this into a triangle and a rectangle, it'll be easier to do. So I was like, I can find the area of a triangle. I can find the area of a rectangle. Hooray! The problem is this guy, right? Because that's in hours and that's in minutes. I want both of them to be in minutes. So let's see if we can fix that. You guys know how many minutes are in an hour? You know how many minutes are in an hour. There's 60 minutes in an hour. So I took that 600 miles per hour and I divided it by 60 because there's 60 minutes in an hour. And that means that we're going 10 miles a minute. So I made a little note over here and I was like, boo, boo. And I was like, this is actually 10 miles per minute. And that's going to make it a little bit easier for me to work this out. Now I can see that for my triangle, I can see that the base is 5. I can see that the height is 10 miles per minute. For my rectangle, what is my base? 5 to 25, that's a difference of 20, right? So for my rectangle, my base is 20 and my height is still 10 miles per minute. So fine, area of the triangle, 1/2 base times height, 1/2 5 times 10. Area of my rectangle, base times height. So we'll just do 20 times 10. Of course, that means the area of my triangle is 25 and the area of my rectangle is 200. So my total area is 225. This means that the jet has traveled 225 miles in 25 minutes. That's a lot further and faster than our car did on the last problem. So my next question is, determine the distance the jet has traveled in just the first 5 minutes when it was taken off from the airport. Go ahead and hit pause to work it out. You know the tricks now, and hit play when you're ready to check your work. Now, we already know the problem of the miles and the minutes, and I'm like, I don't want that to be in my hours. I want it to be in minutes. So again, I'm just double checking my 600 divided by 60 minutes per hour, which means it's actually 10 miles per minute. And I only want this triangle, don't I? If I only want the first 5 minutes, I only want the triangle. So I just have a base of 5 and a height of 10 miles per minute. So 5 times 10, cut it in half, and it turns out that we went 25 miles. That jet went 25 miles in the first 5 minutes. That's not bad. That's not bad. That's not bad. What if I asked you to draw your own velocity time graph? What if I want you to draw your own velocity time graph to model the ascent of a passenger jet, and I'm going to give you a bunch of information. So the jet took 7 minutes to reach that top speed of 600 miles per hour. The jet continued to travel at a constant speed of 600 miles per hour, and the jet left the airport 4 hours ago. Hit pause. See if you can make this work. It's pretty similar to the last one with a few key differences. See if you can make this work, and then hit play when you're ready to check your work. So first of all, I got minutes, I got miles, I got all kinds of stuff. So I don't want this to be in hours. I don't want that to be in hours. I want it to be in minutes. Like this guy is 7 minutes. I want that to be in minutes. So I'm just going to real quick off to the side over here be like 4 times 60 minutes in an hour. So 4 hours is actually, my calculator, 240 minutes. So I want to make sure my x-axis, whatever my x-axis is, My x-axis needs to go all the way up to 240 minutes. That's a long ways, all right? My x-axis is in minutes, blah, 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 all that stuff. Of course, so the jet starts at the ground and then the jet takes off, and after only 7 minutes, and if that's 240, 7's like little, right? 7's like over here. And after 7 minutes, we have hit our top speed of that 600 miles per hour. Except Miss Scott can't write. This is not the prettiest graph. It's not a pretty graph at all. Miles per hour. But we also know now that that's 10 minutes per hour too. So, or pardon me, 10 miles per minute. Oh my goodness, Miss Scott, get it together. I can do it. So if you want, you could do 10 miles per minute. We know that's going to be a problem anyway in just a little bit. And of course, it's a nice constant speed all the way for that 4 hours until we get to that 240. This is not the prettiest graph, but check it out. You just drew your very own time velocity graph. Oh, it's your first velocity time graph. Oh my gosh, next thing you know, you'll be riding around the universe in a tortoise. It's awesome. Of course, this is not pretty, so I'm going to show you my pretty version, okay? I'm going to show you the pretty version. We're going to erase that. There's the pretty version. It's a lot prettier than mine. So let me ask you the question. You know what's coming. Guys, how many miles has the jet traveled after 4 hours? Go ahead and hit pause to work this out. Hit play when you're ready to check your work. All right. I have a tiny triangle over here. So there's like a sliver of a triangle over here. It's not much. And we know the base of that triangle is 7. We know that's not 60 miles per hour. We know that that's actually 10 miles per minute. How many times have we done that now? If you don't believe me, you could do it again. 600 miles per hour divided by 60 minutes an hour, which gives us 10 miles a minute. So there's that. So my triangle, it has a base of 7 and a height of 10. My rectangle, though, I need my calculator because it's 240 minus 7 will give me the base of that rectangle, right? It's 240 minus 7. So from 7 to 240, the base of my rectangle is going to be 233. We already know the height is 10 miles per minute. We've done that many times now. So fine, area of a triangle, 1/2 base times height, area of a rectangle, base times height. 1/2 times 7, 7 times 10 cut in half is 35. 233 times 10 is 230. Add them together and I get 2,365 miles. So the jet has traveled 2,365 miles in only 4 hours. That's awesome. Time to go on a trip. As always, guys, I hope you found this helpful and I hope you found this useful. If you have questions or concerns, please let me know and I will answer them. Come see me during office hours. Ask me during class. You know how it goes. I'll help you out. And I'll see you guys in just a little bit. Bye.